All right, welcome in everybody. So I wanted to go over some problems just to make sure that we filled in any gaps there are from the homework. So if you're having trouble with the homework, I want to show you a few examples. It's stuff you probably picked up along the lessons and videos that you've been watching, but I just wanted to go over a few things so you could kind of see what was going on. So for starters, let's take a look into 2.1. So remember, if you click this title here, it's going to have a short little video for you. We don't want to watch that right now, but you can watch it on your own if you're having any kind of trouble with the homework. You can watch that. But let's go into 2.1 here. So I'll go into 2.1, and we'll go into the teacher preview. And we've got some problems here to work on. So I want to make sure you know how to do these problems because they can look confusing at first, but if you know what's going on, these really aren't very complicated. So we can pull up the ebook here. And I want to show you a couple things. So first of all, here's our definition number 2 for trigonometric functions. Let me center that there. So we had another definition. They really are equivalent definitions, but we kind of had one for when we think about them in one terms, and then here we're applying them to right triangles. So that's one of the things about trigonometry is we have a few different ways of thinking about most of the problems that we work on, and that can be confusing sometimes, but it also can be really helpful because if you're having trouble approaching a problem from one direction, oftentimes you have this other way in which you could approach the problem, and sometimes you can get it completed that way. So we have a triangle here, and you can see our normal convention is that we use capital letters to describe the angles. So angle capital A, angle capital B, angle capital C. And then what we usually do is the side length across from that angle has the same lowercase letter. So notice that the side length over here is little a, and it's right across from angle A. And lowercase b here is across from angle B, and lowercase c is across from angle C. So the letters line up, where the capital letter is generally the angle, sometimes representing the angle measure, and then the lowercase letter is the corresponding side length that angle opens up to. So in this way, we can define the sine of A to be the side opposite of A over the hypotenuse. So here's our angle A. So this is saying the side length over here would be A, so that's the opposite over hypotenuse, right? And you can remember this. You'll often hear people use the term SOHCAHTOA, S-O-H-C-A-H-T-O-A. The sine is opposite over hypotenuse, so S-O-H. That helps you remember the sine part. The cosine is adjacent over hypotenuse. That's the C-A-H. And the TOA, tangent, is opposite over adjacent, TOA. So, S-O-H, CA, C-A-H, TOA, T-O-A. So it just helps you remember these, because if you can remember the definition for these three, you can pretty much work your way to everything else. So people just remember that as a short acronym, SOHCAHTOA. So what this means is if angle A is where we're putting our theta. So we use theta to represent a symbol for an angle. We'll put it in here. So if that's the angle measure we know about, then the sine of that angle will be A over C, the opposite over hypotenuse. Okay. The cosine of this angle A would be B, adjacent, the adjacent side. Adjacent means next to. So adjacent over the hypotenuse, so B over C. And the tangent of this angle right here would be the opposite over the adjacent, A over B. So if you could just remember those three, you can remember the other ones because these other ones are just the reciprocals, right? So you just flip the ones you get up here, and then you get the ones down here. So let's take a look at this example A, or example number 1 in the book, because you're going to have homework problems like this. So find triangle ABC as a right triangle with C equal to 90 degrees. If A is equal to 6 and C is equal to 10, find the trigonometric functions of A. So they want you to find all 6 trigonometric functions. That's fine. Sometimes problems are not going to have a drawing. You should always try to draw yourself a picture when you're doing trigonometry. It really helps reduce the number of mistakes. It helps you figure out problems faster. Trying to do this stuff in your head is not great, right? It actually slows most people down, and you are more likely to make mistakes. So draw yourself a little picture. So the first thing you'll notice here when you draw that, like we don't actually have this side B yet, right? Well, one of the things you're going to do a ton of times in this class is use the Pythagorean theorem. So once you have your triangle, you've labeled the pieces that you know, and you go, oh, I'm missing an angle. Well, if it's a right triangle, your pretty much first step is always going to be use the Pythagorean theorem to get the missing side. So you go through and you do that. You know, this is just a form of a squared plus b squared is equal to c squared, where we've solved for b. So you just plug in your numbers for the Pythagorean theorem. You get 8. So we know that b is equal to 8. So this missing side length here is 8. So then you're going to know the different side lengths, right? So this is really b equals 8, a is equal to 6, c is equal to 10. So then we just use the definitions up here for the opposite and hypotenuse and adjacent and hypotenuse, and we plug all those in. So when they say write the 6 trigonometric functions, knowing that a is 6, b is 8, and c is 10, well, the sine is the opposite over hypotenuse, right? And they say find the 6 trigonometric functions of a, specifically the angle a. So we're putting our theta here at this angle. So the opposite is 6, and the hypotenuse is 10. So the sine is 6/10, but of course we simplify that down to 3/5. Okay, the cosine of A is the adjacent, that's this b, over the hypotenuse. So that's 8 over 10, which of course we simplify to 4/5. And then the tangent is the opposite over the adjacent. So the opposite over here is 6. The adjacent over here is 8. So 6 over 8 becomes 3/4. Now notice if you just go straight across, you've got the corresponding reciprocal function. So you literally just take the reciprocal of these, right? You just flip the fraction here, 3/5 to get 5/3. You flip 4/5 to get 5/4. You flip 3/4 to get 4/3. And that's how you do these problems. You're generally going to start off with the Pythagorean theorem to get the missing side. Then you're just going to use these definitions right here in order to figure out the missing pieces. So there's lots of variations of these problems where there's missing information, and you just have to basically in this class create a toolbox. The Pythagorean theorem is going to be in your toolbox. These definitions right here are going to be in your toolbox. And we're going to pick up other things along the way, like law of sines and law of cosines. And, you know, we're going to build out this toolbox where someone's going to give you a triangle and say, solve this triangle, which means to find all the missing angles and sides. And you just have to be ready to start pulling things out of your toolbox and try them and see if it gives you some of the missing information. So you can see we have similar stuff here. Here's a homework question. Refer to the right triangle below with c equal to 90 as shown. Use the given information to find the 6 trigonometric functions of a. Answer exactly. B is equal to 7. C is equal to 25. So what are you going to do? You're going to use the Pythagorean theorem to figure out what a is. And a is going to end up being 24, just using the Pythagorean theorem. So then when you're taking the sine of a, that means you're thinking about this angle here. Well, the sine of that is going to be the opposite, which was 24, over the c, which is 25. So that's going to give you 24/25, right? By the same reasoning, the cosine of a will be 7, because b is 7 and c is 25. That's going to be 7/25. Right, so you're just using those definitions we had a minute ago, these ones right here. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And you're just putting them to work in these pictures. Okay, just like the problem we just looked at in the book. Okay, for a problem like this, we have the cofunction theorem. It says use the cofunction theorem. So what's that? Well, the cofunction theorem basically tells you if we know about something written in terms of sine, we can write it in terms of cosine. If we have something written in terms of tangent, we can write it in terms of tangent. And you just use these formulas right here in order to do that. Okay, so that's what these problems are asking you to do. And they even have a written example here, as you can see. So you click that and you can kind of see how they worked out a similar example. And then you're basically just going to do the same thing. You're just going to model it after that problem. So you've got some questions on significant digits. Basically, just read the definition here. It's pretty straightforward. You've probably already dealt with these in your science classes. It just gives you the definition right here. That one's not too tricky. So let's take a look at an example in the book about solving a right triangle. So here we have triangle ABC with A equal to 40 degrees and C equal to 12. So a lot of times they'll say, sometimes they list it, find A, lowercase b and capital B. Sometimes they'll say solve the triangle, which means find everything that's missing. Okay, so whenever you see find or solve the triangle, that means figure everything else out. So remember that the interior angles of a triangle add up to 180 degrees. So you might go, wait, I don't know what angle B is. Well, you've got 90 degrees taken up here. You've got 40 degrees taken up here. 180 minus 90 is 90. 90 minus 40 is 50. So that means angle B here has to be 50 degrees because all three interior angles have to add up to 180 degrees. Right? And then what you can do, what can you do? Because you go, well, but I can't use the Pythagorean theorem because I don't have three sides here. What you can do is start using our definition 2 for the trigonometry to start solving for the missing pieces. So say you want to solve for A. So we know that the sine of 40 degrees is going to be the opposite over the hypotenuse. So the sine of 40 degrees is equal to A over 12. So you just write that down. The sine of 40 degrees is equal to A over 12. And then you just solve for A. So multiply both sides of the equation by 12, throw it in your calculator, and you're going to get that A is about 7.7. Right? Once you have that, then you can throw it in the Pythagorean theorem and get the missing side. So that's what I mean. There's no like one way that you're going to solve all these triangles. What you're doing is you're building a toolbox that allows you to think about how to get through these things. Interior angles in a triangle add up to 180 degrees. You've got the Pythagorean theorem. You've got your definitions for the trig functions. So that's what we're going to be using so far. So you just keep pulling those out when you need them. Right? Think about what pieces you know and what definitions do you have that you can use so far.